guys, welcome to the channel. In this video, we will discuss about basics of linked list. We have already covered array data structure in previous videos. You can watch the array data structure and the operation of array data structure in our data structure playlist. Here, in order to understand the linked list, we have to first understand what is the list. List is also a data structure. If we talk about array, array is quite frequently used in all languages. Okay. If we talk about here, I'm talking about only C programming. In C programming, array is quite frequently used. You have used many times array till now. But what is list? List is new for you. It is most generic data structure. In our daily life, we use different types of list. Uh, that is shopping list, player list, to-do list, etc. We have guest list and many more. Shopping list is also a collection of similar types. Means if we go to the market for the shopping, we create first a shopping list, what we have to buy at the shop, at the market, in the market. Okay. Shopping list contains similar types, that is shopping items. Okay. If we talk about player list or to-do list, it only contains the names. If we talk about player list, it only contains the names of players, that is strings. Okay. If we have an integer list that contains the integers in a list, let's say 1 to 100, we have or we have the list of even numbers from 1 to 100, or we have prime numbers from 1 to 100. It only contains integers. Means list is also a collection of similar types, same as array. So we can implement listed data structure using array data structure. What is basic operations in a list? Add operation for inserting an element, adding an element. Traverse, we walk through all the elements we have in our list, that is we use traverse operation. Remove, for deleting an element from a list, we use remove operation. And for finding, for searching searching an item in our list, we use find. Okay. In list data structure, we can say array list. In array list, we have certain limitations. We will see what are the problems with array list. We have certain limitations of array. In array, the memory cells are linked with each other. It means that memory array is contiguous. Okay. In an array, it is impossible that one element of an array is located at a memory location, while other element is located somewhere far from it in the memory. It is located in array, it is all the elements are located very next location in the memory. Means if we talk about this, the first box, second box is uh, on very next of the first box. This cell, each cell is on the very next of the first box, first cell or previous cell. If we talk about 1 and 2, 2 is next to 1 and 3 is next to 2. No other element between them. Okay, we have to put all the cells one by one. Okay, that is meaning of contiguous. Uh, when we declare, there is another problem. When we declare the size of array, it is not possible to increase or decrease it during the execution of program. If we need more elements to store in the array, there is need of changing its size in the declaration. Let me show you. Here we have an array. We can say name of array is A and we have size 10. What if we want to add 10 more elements to it? We have to modify our code and recompile our code for this process. Okay, for adding more elements. And what if we want again and again and again, if we want to add 10 elements, we can change it. If we want to add more 10 elements and after that another 10 elements, after that another 100 elements we have to add, what we gonna do? We will face problems. We have to compile the program again before executing it. Now array will be of new size, but size will be increased. Means here previously we have 10, it will be of 20. But what happens if we again need to store more elements? We will change the code of our program to change the declaration of the array while recompiling it. Okay. To avoid such problems, what are the problems? First, each cells are continuous, one after another. Each cells are located one after another, very next to each other. And another, the static. They are static in nature, and we have to give size problem. If we have to increase the number of elements, we have to modify our code again and again, recompile our program. What is the need? Our need is we can add more elements by only was just writing the elements to it. We don't need to recompile it again and again. What we gonna do to avoid such problems usually faced by programmers? While using an array, there is need of using linked memory, in which the various cells of memory are not located continuously. Here is the new concept, that is concept of linked memory. List using linked memory. Each cell of memory not only contains the value of the element but also the information where the next element of the list is residing in the memory. Means our each cell will have two parts, one for element and another for the information where the next element of the list is in the memory. Means it will have some address of next element so that we can go to the next element. In array we were modifying the indexes and we can access each element one by one. It is not necessary that next element is at next location in the memory. It may be anywhere in the memory. Okay, we have to keep track of it. In this way, first element must explicitly have the information about the location of second element. Similarly, the second element must know where the third element is located, and the third should know the position of fourth element, and so on. This information of next element is accomplished by holding the memory address of next element. The memory address can be understood as the index of the array. As in case of an array, we can access an element in the array by its index. Similarly, we can access a memory location by using its address, normally called memory address. Means what it says means in array we use indexes to access the element of in the array, and in list with linked memory we use memory addresses to access the element at particular memory address. Okay, here by using the concept of linked memory we have, we have introduced a new structure, that is linked list. Means list with linked memory. What is linked list? Linked list is nothing but a list with linked memory. Each element of the list is linked with a memory location. Okay, linked with each other. Linked list is a data structure in which each element is linked to the next. In the linked list, one element holds the address of another element and another holds the next element. Okay, and so on. Here it is a pictorial representation of a node. In a single node we have two parts of a node, that is data and next. Data contains the data object, that is data element, and next contains the address where the next element is located. Okay, it is the address of next element. Next means it is the address of next element. Means if uh, we have at a certain location, and next will tell you where to go next, where we can find next element. Okay, here I have given you pictorially represented list. You can see it has a start pointer that will pointing to the first element. Okay, that is also called head pointer, and each element contains the address of another element 1 2 3 4 5, and at the end the next is null. Here next is null, and it is the end of the list. If we don't have any element into the list will be empty, and our start pointer will be null and end pointer will also be null. Okay, here is another representation of list. I have used only one box. It is only to give you understanding. I have used two representation. First one, this is first one is correct, and other one is only to understand. Okay, this is the original representation of list, means it contains it has two parts. Okay, here it also in the second one it also have two parts, but I'm just showing you each elements are linked with another. I'm just showing you only data elements. Okay, don't get confused by seeing both the structures. You can get this type of structure also if you go through on the internet. Okay, or any books. Linked list inside computer memory. Now I will show you how how the elements of linked list is stored in a computer memory. Each element has each node of the list has two parts. And first is data element and another is address of next element. Okay, now here we have first element, that is 1, and it is located at the memory 1006. It is only dummy addresses. It is not the actual representation of address, but I have just taken 1000 to 1009 to give you proper understanding of the addresses of list element, to give you understanding how list inside the computer memory actually is stored. Okay, addresses of each each element is in hexadecimal, but I'm just giving you for understanding purpose. Okay, the first element is at 1006 and it has the address of next element, that is 1004. From 1004 we will go to here. 1004 is here. Here we go to 1004, that has the element 2, and 2 has the address of next element. We have to go 1002 and 1002 is here. We will go to 1002 and it also has the address of another node and another element, that is 1008. We will go 1008 from 3. Here we will go to, it is pointing to 1008 and it has another address of the next element, and that is 1001, and we will go to 1001 from this location, and that is 5. But note that when we reach the 5 also contains the address of next element, but the next we don't have any other element, we don't have next element, that's why it is written 0 0 or null. We have address null here, means it shows that our list ends here. Okay, this is how linked list inside the computer memory is stored and represented. Okay, now we have W linked list. Linked lists are basically of three types: singly linked list, singly linked list, doubly linked list, and circular linked list. Here it is singly linked list. It is pointing to one side only. But what if we go to 5, 1 to 2 to 3 to 4 to 5? What if we return backward by pointing? If element 5 is pointing to element 4, also we use another arrow that points 4 to 3 and 3 to 2 and 2 to 1. That is that that means we moving from start to end, and now we are moving from reverse start to reverse end. Means we were moving from we were moving forward, and now we are moving backward from end to start. We were moving from start to end, and now in doubly linked list we move from end to start. Okay, here it is a node of a list. Node one single node. This is a structure of doubly linked list. How we move forward, and if we only move forward, we had only two parts of a node, that is data and next. And if we have to move backward again from 5 to 4, 4 to 2, 2 to 1, we have to add another pointer. We have to give the address of previous node, that is previous. Okay, this is pointer that holds the address of previous element. Means if we talk about 5 next element is null, means we don't have any element, and the previous element it has the address of previous element at the starting, and it will go to 4, and 4 also has the next element of next address. At the next it has address of element 5, and at the previous it has address of element 2. Okay, here you can see start and moving back, moving forward, and here we reverse start from backward to forward, reverse start to reverse end. This is how W linked list represented. Okay, we can move to any element and uh, from any node to any element. Okay, in the W linked list. Now we have circular linked list. In the circular linked list, it forms a circle. Means how it forms a circle? It starts, let's say it start from 1, it will go to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 1. Means the last element, means the next address. Here you can see the next element. Here the next element was null, means we have end of the list. Okay, here the next element is pointing to start node. Okay, means the last element points to the first element, that will form a circle, that is called circular linked list. While traversing this type of list, we can spin into infinite loop. Okay, we have to uh, keep track of the elements. In circular list, while traversing, we have to take consideration of terminating condition. Means if the end pointer is equal to start, end pointer will become again start, is pointing to start pointer. We have to break the loop, and we have to move out. Okay, Operations on linked list. What are the operations of linked list? We have insertion, deletion, traverse, size is empty. Insertion at front or back means we push back, we put an element at the last, we insert into the list at the last and at the front. It is big O1 operation. We just put the element in one step operation. Deletion, delete the node with the given pointer, that is big O of 1 operation. Traversal, in the traversal we have to move from start node to end node, means we have to walk through each element. If we have 5 elements, we have to walk through all the 5 elements and we have to print each data element. And if we have 100 elements, we have to walk through 100 elements. And if we have n elements, we have to walk through all the n elements. What is the size? We can also count the size while traversing the element. It is also big O of n operation, means we have to move from start to end. Okay, is empty. Find if the list is empty or not. It is only big O one operation. If our start node is empty, start node is null, it shows that our list is empty. Okay, otherwise it is not. It is only check the first node. That's why it is big O one operation. Uses of list in computer science. If we have huge datasets to store, we use linked list. For representing other data structures, we use linked list. In the tree and graphs, if we have to represent tree and graph, we use linked list. Uses of linked list in real world. What is the uses of linked list? It is used in image viewer. Hope you understand the concept of the linked list. If you understand, subscribe our channel Programming Influencer and like my video, share with your friends, and thanks for watching. Happy coding.